Okay. So now, yeah, we're recording it. Okay. So now what we'll do is we will put fence surrounding the substations, and from where we get it? We get it from uh, uh, you know, this left panel, this library. This is insert electrode. It says insert electrode. This is a hammer. You can see a hammer and this symbol. Did you find it, everyone?
Yep. Yep.
Yeah. So you click on there, and this window will pop up, and here all the item we need in order to make a grounding system is there. We have rectangular ground mat, horizontal ground conductor, single ground rod. We will use single ground rod. We will use fence number 4. Okay, and horizontal ground conductor also will use. These 3 things we'll use. Okay, that what we'll be using. There are many other things. Okay, so we don't need to use them. So pigtail and connector, we don't need them. Only 3 of them will be using.
Sorry, Nurul, just what's the name of the window you clicked? I cannot find it.
This one.
Oh, okay.
See
All right,
the
thanks.
hammer on that one.
Yeah, thanks. Sorry.
Okay, so we are working on fence now, right? Our layer number 2 is fence layer. So select the fence and see they're grouped together. Group main grid. It says main grid. So this fence is a part of the main grid. So whatever is part of main grid, they're automatically connected with each other. Okay, so select number 4, fence post array. Okay, and click on insert. You will have a pen like this. Okay, now you using this pen, you will put pen surrounding your substations. Now each substation should have a gate. A gate you should have. Okay, so in mine, my gate may be somewhere here. So I'll start to put the fence post array from here, in this corner and that corner and that corner and that corner, a little bit in here and little bit in here, and right click on the mouse, and here is the fence already. I'm having the fence already. I have the fence. Now,
So with my substation, there's like a road that goes around it.
yeah, you will put the fence surrounding your substations where all those things are. You should have that.
Okay.
You know.
I think yeah. Okay.
So this red is. I will change the color of my fence because it is not that visible. So I'll choose another color. Maybe I'll use that one. So this is not necessarily, you can use whatever you want, but so yeah, this is my fence. Now it is visible. So everyone put fence surrounding your grounding grid.
Is there anything special you have to do for the end for the gate, or you just right click and it's done?
So when you're done, you keep the gate area open.
Okay.
And right
just
click.
Yeah, leave a little space between them.
Yeah.
Okay.
Any question?
I didn't leave a space for a gate.
Doesn't matter, then make it here now. So you select it and you move it. This one you can move, see? You can put it here, you can move it. So make it, it is not a problem.
How do you make it green?
I went to the layer and I changed the color here. See, it says color.
Oh, okay, thank you.
Yeah, that's the way I did it. So now my fence is done, but try to make it accurate, very accurate. Okay, so If there is any corner or whatever, make sure that you are taking care of the shape of your substations. So what I'll do is I will deselect the edit of fence and apply and accept. So now this fence is already permanently set up. So no one can edit it. I won't edit it because after that I have to put some other ground component within the within the grounding system. So I deactivated it. So now you can have a look on it. So go to the left panel and you will see X, Y, Z 3D perspective view. Did you find it?
Yeah.
X, Y, Z. Click on there, and when you click on there, you will see this fence surrounding your substations. The gate is empty, and this part is the metallic fence, and this is the fence post, and they are driven into the ground, and by default they are driven around half a meter. Okay, you don't have to change anything, you just keep it. So you could have a view like this. Okay, so in your report you'll include everything. You will include the two-dimensional view and three-dimensional view, everything. Okay.
Is there a way to like actually change the Z plane as, or I guess what plane would this be? Like right now I can only zoom in and out. Is there a way to change the different planes?
No,
It's kind of like it's just stuck on one angle. Like if you look on your top right, see how like your Z, Y, and X are kind of just staying the same. But like in AutoCAD, you could technically rotate it.
Yeah, AutoCAD you can rotate, but here no, you cannot rotate it.
Okay.
You can rotate it, but you can look at here. You can make another one. Here you can rotate it this way.
Okay.
See, you can rotate.
I don't know how you got there.
Sorry, which one did you hit?
You just go to the, I'll show. No, this one. Go here. So you can see here X, Y, Z with a ball in here.
Oh yeah. Oh yeah. I
Click
see
on
it.
this one, you'll get that. You'll get that, and if you want to go back, then you have to close that one. And from this view, you can go back to two-dimension view by clicking X, Y. This is two-dimension view, top view. You click on there, you will go back to top view. All right, so yeah, using just X, Y, Z, you don't have any option to rotate it. You cannot do that. You don't have to. It's it's good enough. All right, so we are done with fence, right? Everyone done, right? Any problem? Any question?
Yep.
Okay,
I'm good.
now the layer you already deselect the edit for fence, right? Now make active layer number 3 and name it. Let's say ground rod. We'll be putting ground rod in here now. Okay. So in third layer, we'll be putting ground rod. So we will pick ground rod from the same library here. Insert electrode, click on there. And here we're having ground rod number 3, single ground rod. Select it.
And this is not on the same layer as fence, right?
No, it is different layer.
Okay.
It is in different layer. It will be different in layer number 3.
Okay.
So insert and you are having 10. So in each corner, you put a grounder. So this 3 feet means you are having ground rod with a length of 3 feet. So now once you put it, you don't have any more with your mouse. So what you can do, you can copy it and paste, or you can go back to the library again. Okay. The way you
Sorry,
put-
Neural. When I did that, when I don't have the 10 feet pop up. Is there a certain?
you
am I
don't
doing
have
that
10
wrong, or-
feet. You don't have any
No.
number, right?
No.
That's okay. That's okay. Just by default, it is 10 feet.
Okay.
So, yeah. And it is also related to group main ground. It means automatically this ground rod is connected to every component under this main ground.
Neural, also, if we don't have like a perfect square substation, do we have to put one in each corner kind of, or?
Yeah, put it in each corner. It doesn't
Okay.
bother you.
Ah, shit. Yeah, if you copy and paste it, it's like you, when you go to move them, it moves them all at the same time. It's kind of weird.
No, it shouldn't.
I don't know. I'm just terrible at this software, I think.
So then what you do, you select when you copy and paste. So let's say you copied this one and you're pasting here. You're having two side by side. If you move one, all of them moves, right? That's what is problem.
Yeah,
So you select them, you select one, both get selected, right? Then here you see a chain, broken chain.
yeah.
You
Oh,
select
okay.
them and click on the broken chain. Then it seems like both are getting grouped together. So you break the group by select them and break the chain, and then you will be able to move them separately. Does that work?
I'm just gonna do them individually. I don't know. Doesn't work.
I heard the little pew. Something
Yeah,
happened.
something. You heard that? That's funny.
Yeah, there shouldn't be that problem.
I'll figure. It's okay. I found another solution. Breaking the chain does not work though.
Okay, if you found some other solution, then use them. Yeah, put the ground rod in each corner.
So there's no harm in having like too many of them, right? I put a ground rod at like each point that my fence changes
So
angle.
in terms of the performance of the grounding grid, it is good, but
Mhm.
in terms of spending money, it is not.
Yeah.
I mean, it's
It still
infinite
costs a
budget.
bit. Takes a bit of time to make each one of those happen.
I guess if it's going 10 feet, isn't it?
Yeah.
10 feet down, right?
I think I've done grounding rods a few times and they can take a long time.
Yeah, grounding rod doesn't take that much, but grounding conductor will take a lot of. So the sound, some of you are having sound, right? If you want to mute it, click on tools here, see tools, and then general options. Okay, this window will pop up, and this graphic user interface, there is a button GUI, click on there, and here you will see sound. You can off the sound. You can choose the off.
Mine already was already off, but I get like these cute little Star Wars sound effects.
So warning sound, you can deselect warning sound. Maybe you are having warning sound, that's why. So
Getting like
what
a
you have
little
to
pew
do is
pew.
just here.
I like the little warning sounds.
Pew!
Yeah. Okay.
Sorry, Neural, go ahead.
No, it's okay. So everyone has ground rod installed already, right?
Several.
So yeah, I would suggest you to do it right now. You won't have to spend time on that. And you can have a look on 3D also, see each corner you're having. Each corner you're having grounding rod. And you can put it nicely just underneath your fence. Okay, you can move it if it is not nicely aligned in the corner, right in the corner.
Oh, how do you get to this view?
Hmm?
How do you get to this view?
So XYZ, 3D,
Oh,
that view, yeah.
and so it should be touching the fence, right?
Yeah. So it doesn't matter if, so for beauty, you can put it like this. But this fence and this ground rod are in one group, main ground. So whichever in the common group, all of them are connected together. You don't have to make a connection. They're already connected.
Okay.
By default, they're connected. Okay, so these two things we have. Now we have to install ground conductor. Okay, that will take longer time. I will just show you. You'll do it at home because it will really take longer time. So you have everything now. Go to the layer and deselect the ground rod one because ground rod already done. Now activate layer number 4 and here put the maybe ground conductor will be appropriate. Ground conductor. Okay, layer number 4 ground conductor, apply and accept. The color ground conductor is blue color. Blue color is not good for me. I will change the color there. But for you, not necessarily you have to change it. You can keep as is. It is up to you. Let me use this one if it will be better. Okay, so again, we'll go there, hammer. Number 2, horizontal ground conductor we have here. Okay, so now one thing I should tell you that ground grade will be underneath the surface of your substations, covering all areas surrounded by this fence. Now on top of that, 1 meter away from the fence, you have to install ground conductor, okay, surrounding your fence 1 meter away, and that conductor is called counterpoise. So everyone should install that counterpoise first.
So
So
you said 1 meter outside of the fence
outside,
boundary?
yes,
Okay.
outside, 1 meter outside. Now, how will you measure the distance 1 meter? You need right 1 meter, exact 1 meter. So you click on this one, see the cross with a dent here,
Yeah.
insert reference object. Everyone click on that, and number 7, you'll see dimension line. Okay, so select the dimension line and insert. You will have pen, and here you will get a scaling line. Okay, depending on, so So make it 1 meter. Change it to 1 meter. Yeah, it is a bit of work. You have to be patient and
It goes from like 0.82 to like 1.7.
could be, but you have to do it.
Okay.
It can't really do like diagonally either, eh?
Yeah,
Like
I'm having an
it
issue with that.
stays at 1 meter if you're going like perfectly horizontal or vertical, but otherwise not so much.
So 1 meter this way.
It only knows like 0 degrees, 45 degrees, and 90 degrees.
Yeah. So
It
so you
doesn't
can you can
know.
move it. You can move it. You grab
Oh,
one.
I got a
one
meter. Nice.
you,
There we
you
go.
can grab one side and move it. Okay, so this is the way in each corner you will find the distance 1 meter. Okay, each corner. I'm not doing in mine. I'm just showing you that the way you will get the scale, and you'll go to this library and you will pick your ground conductor from number 2, insert, and you will have your ground conductor. So make sure that all of them are 1 meter away from your fence. So I'm just putting mine. I'm not looking at the distance, but you have to. This is counterpoise, and counterpoise is always outside of a grounding system 1 meter away. Doesn't matter how big your grounding system is, but it should be there. The counterpoise, and counterpoise we will cover. It won't keep any gap in your gate. Okay, no gap in your gate. So counterpoise will be.
Is there a way to like add another junction point to it, or do you just have to keep installing new lines when you want to like slightly change the direction?
Junction point. See, if you go there, horizontal ground conductor now. There is slant ground conductor. So here is one type of ground conductor. Yeah, you can use that one. It will save you time. Yeah.
Sorry, which one was that? I missed that.
So use that one instead. Number 10. Number
Okay.
10, you can use like fence. Okay, so you can just put your pen in different point. Number 10, use number 10. Yeah, that's the best one. Polygonal ground conductor, insert, and then you can put here and go there and go there and go there and go there and go there. Yeah, it will be much more faster. Put your counterpoise surrounding the fence, and after that you make the distance. Okay, when you're done, you just click on right knob on your mouse and you're done. Yeah, instead of using number 2, use number 10. Okay, so this is the way you will install the counterpoise surrounding your substations outside of fence 1 meter away. When you're done, you will click on the layer and deselect the edit of grounding conductor. Oh, no, grounding conductor, no, it is not done yet. I'm just, so ground grade, now ground grade is the important thing. Okay, so ground grade, again, you can use number 10 or number 2, whichever you feel convenient. Now, underneath the fence, you must have ground conductor. And ground conductor, you go all the way. You don't have to keep the gate again. Ground conductor should be ground conductor should be everywhere. Okay, you have ground conductor underneath your fence. Now, from that ground conductor, you will put ground conductor to horizontal and vertical direction 10 meters away from each other. So now you are making a real grounding grid. Okay, real grounding grid you have to make.
Sorry, Neural. So we need the outside grounding conductor 1 meter away, all the way around,
Yeah,
and
that
then
is
one
called
directly under the fence.
one direct under the fence, and then within the fence, horizontal and vertical direction 10 meters away from each other.
I don't get this software, man. Holy moly. It's like the minute you make it like a new ground conductor and you try to like drag it to the other side, it like brings every single thing that you selected with it. Every single line.
Really? Is there anyone having the same problem? So if that is the problem, I think,
Yeah, I'm having that problem too.
yeah,
It's like,
you could close it and open it again. That the way I think you will be able to solve this problem.
Sorry, Neural, what is it after we do installing it below the fence? So what do we do after that?
So below the fence, you have the conductor already. Now you will install the grate within your fenced area, and the distance from conductor to conductor will be 10 meters, and those conductors will be horizontal and vertical. Just you are making a grid.
And Rule, the horizontal conductors in the middle of the substation, do you connect them to the fence or to the other ground conductors?
No, up to the fence.
Up to the fence, okay.
Yeah.
And Noro, does it have to be exactly 10 meters? Because mine's kind of at an angle and I can't get it at 10 meters for the dimensions.
So so most of the part you have
Yeah.
to follow 10 meters, but definitely you will come to a point where 10 meter doesn't fit.
It's-
Then yeah, at that point, at that area you could make less than 10 meters or a little bit more than 10 meters. That's fine.
I could do like, because mine's at like an angle. I could do 10.2, but I can't get, for whatever reason, I can't get 10 meters with my dimensions. That's
So
the issue
you'll
I'm
be
having.
able, you will be able to. So see here,
Okay.
different option you have. The left panel, you click on them and they will allow you to do the exact 10 meters. Will be able to make it. There's a snap to grade, and here is a orthogonal snapping, and here is another option, snap to nearest line,
Mhm.
and a snap to nearest vertex. So you use these four, whichever fit you, in order to make exact 10 meters. You will use that one. Okay, just play around.
Right.
And this conductor you can just copy and paste, but put them exact 10 meter away from each other and make a grid. Okay, so you know how to make the grid, and you know from where to pick this element, right? No problem about that. You don't have to do it right now, but right now what you have to do is to know how to do that, and later on you'll do it, because this is the part which take a little bit of time. Okay, so I'll show you how to do what to do next. What to do next? That's the objective. So whatever I didn't complete my grounding grid. I think you also didn't complete, but you'll complete later on. But what you have to do after completing this grounding grid, that will be the topic now. So save it. Okay, so you have now your complete model, grounding grid model. Okay, including the fans and counterpoise, ground rod, and everything. So this is your grounding grid. Now this grid is located on the soil, which resistivity you already have. Okay, so as if this is your yeah, I can deselect this ground conductor so it will move. So as if you took the reading of soil resistivity from here to here in that direction and that direction and that direction, 3 different directions surrounding this substations, you took the reading of soil resistivity. Now that soil resistivity data you have to put into the software. Now software know that this is your grounding grid, that much conductor you are having. Okay, that is the fence you are having, that's counterpoise, everything you have, and based on that your analysis will be done. But analysis we are not going to do today, but we'll use the soil resistivity, considering that the soil resistivity measurement was done surrounding these substations or your substations, whatever substations you are working on. So what you will do is you will click on this one, see soil data interpretation. So this is similar to Wiener 4-pin method. You click on this one. Okay, when you click on that, this window will pop up. Everyone should have this window. You have it?
Yep.
Have it. Now check Wiener method, 4-pin method, this second one. Okay. Wiener method, second one, and then edit / process. Click on that. So you'll have this table here, Wiener method field data. Okay. So that's what you will have now. So now you have to go back to your lab number 2, where all those data you are having. Okay. So first see here, you are having first column and first reading here. Probe spacing. So our probe spacing was 2 meter first one, right? And second column, probe length. Probe length you'll put 0.3. Okay, this one also 0.3, the third one. And here you have to put soil resistivity. Okay, for 2 meter probe spacing, the resistivity you have, that number you have to put.
Nurul, you have like the Zoom thing. Oh, okay, it went away now. You had the Zoom thing like in front of the window, but it went away now. So never mind.
So is it better now? Or
Yeah, it just came back now for some reason, but it's yeah, down there it's not in front of it, so that's better. Thanks.
so yeah, so anyways, here in fourth column, you have to put the soil resistivity, and you'll put it from the table, data table, which is provided with the lab instruction. I don't remember what is the first number, maybe 277 or whatever.
Well, first we need the resistance and then resistivity, right?
Oh, this it's resistance. Yeah, I put the
Yeah.
resistance, whatever resistance you have.
So it was 3.9 and then 49.
3.9.
Yeah.
And this resistivity you don't have to. It will calculate itself, and
Oh,
it will match the number. Okay, so you have to fill up only this 4 column. In this 4 column, second and third always will be 0.3, 0.3, 0.3 everywhere. But here the distance, first distance is 2 and second distance is 4 and then I think 6, right? So whatever distance, you look at the table and put the distance, and here resistance only. And when everything is done, you will click on this update button. Okay, the resistivity column, there is update. You click on there and it will calculate the resistivity by itself. Okay, so that's what you will do after completing this table. And when you are done, see the operational frequency here 72 hertz, but our frequency was 128. Make it 128 hertz. So only thing you change from here, this one. And number of layer is 2. Okay, I think it is default. If not, then you put you pick the second 2 layer. Okay, so when you are done, you will click on process here. So process here, it isn't working because we don't have enough data. So when you will have enough data here, then this process will be fine. Okay, now I will show you. So I will open another WinIGS. I'll stop sharing this one. And another WinIGS, I have all the data already set up. So using that one, I will using that one, I will show you. Let me open another one. Give me a second.
For the probes placing or the distance, which one do we use? Just the one between, because you have like 1 and 3 and 2 and 6 and 3 and 9. We're just using the 1, 2,
No,
and 3.
that is
Oh,
that is
sorry,
not what you
sorry.
will be using. It is just showing you the
Okay.
how to make
Yeah.
the distance. Okay, so
Yeah,
the second column.
My bad. I
is-
see it.
Yeah.
I see it now.
Mm. So yeah, you keep on working. You keep on working with your project. Put the resistivity. Okay. So everyone put the soil resistivity from first table. Okay, from first table, and then I will show you what to do next.
So do we keep the probe length at 0.3 throughout?
Probe length, yeah.
Okay.
0.3. Yeah. So yeah, everyone put the data from first table. Okay.
And then as soon as we have it in, you just hit process, right? Or finish.
You're gonna get a scare.
What was that? Sorry.
You're gonna get an interesting
Try
sound.
it out. Try it out.
Hit process.
You're gonna get an interesting sound.
Yeah.
Spook you a bit.
Oh, geez. Oh. You still there, Neural?
Okay. So are you done with data entry?
I think so.
Okay, sounds good.
I don't know
So,
about everybody else though, actually.
okay, whoever is not done yet, you will do, but I will show you what to do now. So this is the grounding system. All right, let's say this is the grounding system. This is the grounding system. You put the fence and ground rod and counterpoise and a grounding grid. Maybe not done yet, but you will complete it. I'll show you using winner method. You put the these values there. So here you don't have to put the soil resistivity, okay, but you'll put the resistance, and then if you click on update, so this software automatically will calculate the resistivity here. Okay, now you will accept it and edit again, and the process here, process, you'll click on the process. So by clicking on the process, you will get this this model. So this window represent the 2-layer model of your soil based on the soil resistivity data you used, okay, in this winner to 4-pin method.
So when we go to put in the other tables, do we just continue on with this list? Like
No,
continue it down,
thing,
or
wait
that's
a
separate?
bit. I'll talk about that. So you will have this 2-layer soil model, and in this model, this is a first layer, this is a bottom layer. Top layer resistivity that much, and bottom layer resistivity that much, and the thickness of first layer is 18.3 meter here. But see, the upper layer resistivity is having some tolerance of 45.4 meters. So with this number, you can add up any number up to positive 45 or negative 45 if you need to. Same thing with the height or depth of the top layer. You can add up or subtract up to 14 meters. Sometimes you have to, change these values in order to make your model reasonable, okay, or acceptable. So at this point, you won't change anything here. Whatever you have, just you copy it and paste it, keep it somewhere, because in your report you have to include this. This one you will copy and save, okay, and this data also you will copy and save. So for one traverse, one set of data for particular traverse, you are saving 2 figures, one with the data and this graph, and another with the 2-layer soil model. Okay, you are done with that, and you can close it. So you can go back to your model. So you put your soil resistivity data for traverse 1 in here. Okay. Now, what I would suggest you to do is to copy this grounding system and paste 3 times, copy paste 3 times, 3 more grounding system you will make. So they will be the same because the grounding grid you already installed there, that is with all of this grounding model you will have. but soil resistivity of all of them will be the same. So that's why the first copied grounding grid, you will name it as north south or east west or northeast southwest. So these three traverses data you have in your lab instruction. So if the data you insert in this model is from traverse north south, then write it north south and keep it. And you open the next one and you name it according to the second table, second data table for maybe for east west or northeast southwest, whichever you have, you name it accordingly. And you open this one and go back to this soil data interpretation knob again and winner method and edit process, and here you will change. So what you will change? Only this one table, because these are the same for the next traverse. Only resistance will be different. So that number you will change and update again. Okay, and process, and from this second traverse data again you will save two figure. One will be this one with new data here, and the second will be this one with two layer soil model. But in that soil model, the top layer resistivity, bottom layer resistivity, and top layer depth will be different because your number here will be different.
Sorry, could you repeat? Did you make a new grounding grid system there for like how do you have those three new ones on the single line?
Okay, let me show you how to do that. So yeah, that would be a question because
like those aren't true ground systems, right? They're just like models of it, kind of.
it's a model, yeah. So I'm gonna delete all of them. Okay, so that's what you have. And in here,
Sorry to interrupt. How do we get to this page again, the schematic? I'm still stuck on the grid. How do you open up the schematic?
schematic here, see tiles, 4 tiles. Look
Yeah.
at here. You click on there.
Yeah. I'm clicking on it, but it's not popping up. I think I'm stuck in the. Is there another way to open it up, or?
Okay.
You might have to like minimize your ground grid or something like that, and then I've got little tabs on the bottom
Oh, okay.
that I can enlarge.
So this one you have, right? You click on this ground grid, you will have 2 of them. So you can maximize your grade itself. Okay, you have only one. If you want to get back the overall grade, you click on here. You will get them. Okay.
Okay, thanks.
So you can close this one, but don't close this one. If you close this one, pressing this cross, then you have to reopen it. Okay. All right. So yeah, let me this. I want to. Okay, let me. You are having this one. What? So this should be complete in terms of installation of grounding grid, fans, ground rod, and counterpoise. You already have ground grid. You will complete it, and in here you will so this one you will complete putting the resistivity data as well. So everything should be completed. Okay, so when you are done, with inserting the resistivity data. You can close it, and this one just copy and paste and paste and paste, make 3 of them. So put it in a same level and name them. How you'll name them? You will, so for now, each of them are having the same data, same grounding system and same data put in here according to the first data table. Okay, you look at what traverse that data table represent. If it is north south, you put here north south and don't change anything. Okay, now this one you name as the data table, second data table, and the third data table. Okay, these two you will name according to second and third data table, and you will click here. You will get this one, and you will go there again, and winner method, edit process, and in this table you will put resistance from second table and update and process again, and 2 figure you have to save for that second table data. You are done with that. You will close this one. Okay, and then you will it is better to close this grounding grid which you are not working with. You will be working with this grid, so open this one. Okay, open this one, and this will be a ground grid where you will insert the data from traverse number 3. So click on here and winner method again, edit process, and here again this column you will change. So data of resistance you will put here from the table representing traverse number 3. And the same way, update and process, and from this data from table number 3 or third traverse, again you will save 2 figures. Okay, so by doing this, you are basically making grounding model, 2-layer grounding model for 3 different sets of data. For final analysis, you need final model. Okay, and for that final model, the top layer soil resistivity, bottom layer soil resistivity, and top layer soil depth, you have to prepare out of those 3 models. 3 models you combine together and you make a final model. And using that final model, you will continue to analyze your grounding grid. Okay, so whatever I discussed could seems a little bit complicated, but it is actually not. If you pay good attention, then it is not. So whatever done with the first, that things you will repeat only. So again, I'm repeating, in terms of grounding grid, every system will have the same grounding grid. Only the resistivity data of these 3 grounding system will be different. And for that different resistivity data, all of these 3 will give you 3 different 2-layer soil model. And for that 2-layer soil model, you have to save their 2-layer soil model and the data you inserted for each of these grounding grid.
So why is it that we install, or like we put in the information on the main ground system just from like the first table, but then the other
So
ones?
why we did this? Because when we are done with data entry, so resistivity data entry, we'll make a final model. Okay, so final top layer soil resistivity and bottom layer soil resistivity and top layer depth. Okay, we'll have it, and that data will insert here, and that will be our main grounding grid, final grounding grid, and we'll analyze this one, and these three will deactivate. You can deactivate is double, yeah, let me see. You'll deactivate is double clicking of your mouse, right mouse button. See, you are having dotted line, so as if they are separated from this system, and the main data you will get out of these three different model we'll put here. We'll click in there. Okay, so I don't know which one is. Let me uh let me close them. Yeah, close them, and so we'll click on there. So this is our main grounding grid, which we'll use for our further analysis. So in here, what we'll do, we'll put our soil resistivity, top, bottom layers, and the depth out of all those three soil model, and we'll go there. And instead of winner method, we'll use this user specified multi-layer soil model. This one, and using this one, we'll put the resistivity we got out of these three. So from out of these three, we'll have three data for top layer, three data for bottom layer, and three data for the top layer depth or thickness. So out of those three data, we'll make one data, and that data will put in user specified multi-layer soil model. We'll click edit process, and here manually we'll put that number, and here manually we'll put that number. This is bottom layer soil resistivity, top layer soil resistivity, and here the height, and we'll accept it, and we'll go forward.
So
Okay, so
sorry, with that, I guess, do we just average those other three results then?
yes, that's what
Yeah.
we'll
Okay.
we'll make the average. Yeah, you're right. So that part will be you know that part will be the part of our next lab, next Saturday. I mean next Thursday. So far, whatever I discussed, definitely you are not able to complete your grounding grid. You will complete the grounding grid, and you will insert the resistivity data in all of those three models. Okay, and save three two-layer soil models. For each models, you must save 2 figures. Okay, so 6 figures you have to save from these three, and we'll continue our discussion in our next class. Okay, so this is all for today's lab, but again, if you have any question related to what was discussed already, go ahead and ask me. I'll repeat it. If not, then we'll dismiss our class today, and we'll continue with the rest of our modeling.
So Neural,
Yeah.
you will be posting the recording on D2L?
Yeah. So I think I'll be able to do that. I have to. It is done differently. It should be done differently. So recording is still recording. So let me stop sharing, and then it is a recording. So I will so in more it says rename. So if we'll end up, I think it will ask me to record it, and I will record it and I'll post it. If there won't be any problem, definitely I'll do that. But because previously I didn't do this recording, I think. Anyways, I'll try. Okay.
Okay.
Yeah. So here is the I'll